Good morning students. Today we are going to study about similar triangle. This is very interesting chapter of class 10 and very important also. So let's recall something that you already know. In your day-to-day life, you have already seen many objects. They are equal in shape and equal in size. Okay, for example, I can say two same coin of rupees 5. Okay, and you have seen other object also. Okay, those are equal in shape but not same in size. For example, you have seen a train and a toy train. They both are similar to each other. So just recall our ninth class knowledge that about congruency. See, in congruency, we know that two figures are said to be congruent if they have equal shape and equal size. For example, two coins of rupees 5, they are congruent to each other. And in ceiling fan, we have all blades congruent to each other. So student, what is congruency then? Congruency means two figures, those are same in shape, equal in size, are congruent. In easy language, you can understand that if I will put first figure on other and vice versa, then it will superimpose each other. Okay, so it is clear that congruent figure are same in shape and equal in size. Now let's go for similar figure. In similar figure, two figures are said to be similar if they have equal shape but not necessarily the same size. Let's talk about our picture photograph. You have stamp size photograph, sometime you have passport size photograph, and sometime you have postcard size photograph. Here I have shown great Ramanujan mathematician, great Ramanujan's picture. This is in stamp size photograph, this is passport size, and this is postcard size. So in all, image is same but the size is different in all the case. So you can say that two figures are similar if they have same shape but not necessarily the same size. Okay, now question arises that if two figures have same shape are always similar, then your answer should be it depends. If both figures have only one changing parameter, then answer will be yes. For example, all the circles are similar. What is reason? It depends on only one parameter, that is radius. So you can say that all type of circles are similar. Now let's go for next figure, that are all squares are similar? So again, here it depends only on one parameter, that is side length. That's why all type of square will be similar. Now we have equilateral triangle. In equilateral triangle also it is the same case. In this case also you can say that all the equilateral triangles are similar. Reason behind it, that again it depends on the side length only. Only one parameter is there, that is changing. Okay, so I hope that you understood that all the circle, all the squares and all the equilateral triangles will be similar. Now next question arises that are two rectangle always similar? So students, its reason is, in case of rectangle, similarity depends on two parameters, that is length and that is breadth. Parameter, that is length and breadth. Length and breadth. Okay, so here two variables are there, length and breadth in both the case. Okay, for example, I am taking length as 5 centimeter and breadth as 2 centimeter. Okay, and in another rectangle we have length is equal to 10 centimeter and breadth is equals to 4 centimeter. Now if you are giving me this condition, then we can say that rectangle is similar. Reason, both length and breadth should increase or decrease in the same ratio. Now understand what is same ratio. Now student, you can see here its length is 5 in first rectangle. Now it changed into length is equal to 10 centimeter. So we have doubled it. Okay, it is 2 times we have done. Now about breadth, you can see that B is 2 centimeter here, and here we have made it double. So if I will say that ratio of length of first figure and second figure will be 5 upon 10, that is equals to 1 upon 2. Similarly, if I will get ratio of the breadth, then I will get B upon capital B is equals to, it is 2 upon 4. Here also I am getting same answer, same ratio, 1 upon 2. So students, all rectangles are similar when it following this case, that it change in the same ratio, its length and breadth are changing, or you can say increasing or decreasing in the same ratio. Okay, so this is about rectangle. Now see here, we have one note now, that you know that congruent figure are equal in shape and size. So you can conclude that all the congruent figures are similar, but all the similar figure need not be congruent. How? See now, two figures are given. These two coins of rupees 5, they are congruent, as well as they will be similar, because I told that changing parameter is only radius. So circle is always similar. Now let's go for second figure. These figures are similar. Okay, why it is similar? All the angles are equal, you can say, and it is equilateral triangle. So in equilateral triangle case, you know that if all the sides are 3, 3 and 3, and in another it will be 4, 4 and 4, then again ratio of the sides are coming 3 upon 4 in each case that you are getting. So these are similar, but you tell me one thing, that if I'll keep this first picture on second, or second on first one, are they going to superimpose each other? No, they are not going to superimpose each other, because they are not equal in size. So student, this note you remember, congruent figure are always similar, but similar figures need not be congruent. Okay, now let's go for next. Here student, it is given, come on similarity of triangle. This is our main topic of the chapter, similarity of two triangle. Now student, two triangles are similar if it is following two cases. First case is if all three angles of first figure is equal to another three angles of the other figure. Okay, this is first criteria. What is criteria? Their corresponding angles should be equal. Now their corresponding sides in the same ratio. Now I am explaining you, suppose this is triangle ABC and this is triangle PQ and R. If I am giving you this angle 70, this angle 30 degree, and this angle I am giving you 80 degree, and similarly in other figure I am giving you this angle 70 degree, this angle 30 degree, and another angle 80 degree. So student, you can compare that here in first figure and in the second figure corresponding angles are equal. It is following this criteria. So it is criteria of similarity. Now come on second point, that their corresponding sides should be in the same ratio. Now see how it will be in the same ratio. For example, if its side is 4 centimeter, 8 centimeter, 10 centimeter, okay, and its side is given 8 centimeter, 20 centimeter and 16 centimeter. Okay, 16 centimeter. Now see students, here if you will find ratio of these sides, what will come? Understand, AB upon PQ, AB upon PQ is coming is equals to 4 upon 8, as well as BC upon QR is coming is equal to 10 upon 20, and AC upon PR is coming is equals to 8 upon 16. Now in all the case you are getting ratio 1 upon 2. So corresponding side should be in the same ratio, corresponding angles should be equal. This is similarity criteria for triangle. Let's take another example here. Now see, here on this board I have taken two triangle to explain you that same thing. Okay, understand. In first triangle ABC, sides are given 3, 4 and 5. In other triangle it is given sides are 6, 8 and 10. So student, if I will say that these two figures are similar, what should be your answer? Yes, answer should be yes, it is similar because its sides are changing in the same ratio, or it is increased in the same ratio. Here you know that AB upon PQ is equal to 3 upon 6, BC upon QR is equals to 4 upon 8, and we have AC upon PR is equal to 5 upon 10 centimeter. So student, it is when you will cancel it, it will give you 1 upon 2 in each case. If you will cancel, it will give you 1 upon 2 in each case. Okay. So now you can ask that, sir, but you told that there should be two things, that all corresponding angles should be equal and corresponding sides ratio should be equal. So here how we can say if only sides are in the same ratio, that how we can say that triangle ABC similar to triangle PQR. Now I am explaining you how we can say. Understand, first of all, that if these figure I have taken Pythagorean triplet 3, 4 and 5. You all know that it is Pythagorean triplet. It means this figure is right triangle making 90 degree here. In other case also, this is also Pythagorean triplet. So this is again 90 degree. So student, one angle is equal. Now you are clear. Again here angle C, for example, if I want to find angle C by application of trigonometry, so angle tan C is equals to perpendicular upon base, I am getting it is 3 upon 4. If I am getting angle tan A, then it will be equal to 4 upon 3. So these are angle C and angle A. Now in other figure you find tan R here, that will be is equal to perpendicular upon base, that is 6 upon 8, and after cancellation what I can say? I can say it is 3 upon 4. Similarly tan P angle tan P, it will be equal to 8 upon 6, and after cancellation you will get 4 upon 3. Now you can see that angle tan C is equal to angle tan R, angle tan A is equal to angle tan P, so, and one angle is already 90. So all corresponding angles are equal. Student, this criteria is also known as AAA similarity criteria, and when you are getting ratio of the sides same, then this is known as side criteria of similarity that we will discuss in our next class. Now see, very important thing we are going to start, that is B.P.T theorem. What is B.P.T theorem? basic proportionality theorem. It is also known as Thales theorem. What is Thales theorem? Its statement is, if a line is drawn parallel to one side of triangle to intersect the other two sides in distinct point, the other two sides are divided in the same ratio. What is told? If a line is drawn parallel to one side and it is intersecting other two sides on distinct point, then this line divide other two sides in the equal ratio. Okay, so given part, triangle ABC, where DE is given parallel, DE is given parallel to BC. Okay, it is given DE is parallel to BC. What we want to prove? We want to prove that AD and DB, its ratio should be equal to AE upon EC. Its ratio, we have to bring it equal. Now student, to do it, we have to do some construction. What construction you have to do? First, you join B to E, you join C to D. Afterwards, you draw a perpendicular EN on side AB. EN, draw perpendicular on side AB. EN perpendicular on side AB. And another perpendicular you have to draw, that is DM, you draw on side AC, right? So this is construction part. Join BE and CD. DM is perpendicular to AC. EN is perpendicular to AB. I hope it is clear what construction we have made. Okay, now see its proof in next slide. Here, this is same figure that we have constructed in previous slide. Now understand. Here, you know that area of triangle is what? Half base into height. So students, here first I am going to find area of triangle ADE. Okay. So while taking triangle ADE, I am taking AD as base and EN as perpendicular. So what will be area? Area will be half AD into EN. This will be area half AD into EN. Give it equation number 1. Now we are going to find area of triangle BDE. This triangle, can you see? Yes. Now here this base is BD. Now I am asking a question that what will be height in this case when we are taking triangle BDE? Yes, it is EN. Okay. Why it is EN? I am telling you, student, we have different types of triangle. Okay. This triangle is acute angle triangle. If you will draw height in this, then it will be inside the triangle. Now, if you have right triangle, then these two sides making 90 degree will be base and height here only. Okay. And here it is base, this is height. Now, in case of obtuse angle triangle, if it is BD and if I want height, then height will lie outside the triangle. How? If I will draw this line EN, then it will be perpendicular line EN. So this same case is here. If you understand, BDE is a triangle, BD is base, EN is height. So area of triangle BDE is half DB into EN. Now what you have to do? You divide equation 1 by equation number 2. So area ADE divided by area BDE. So half AD into EN divided by half DB into EN. So you can cancel half and half, EN and EN. So you will get area of triangle ADE upon area of triangle BDE is equals to AD upon DB. Give it as equation number A. Clear till here? We got area of two triangles. Now again we are taking area of another triangle. We are taking area of triangle ADE. But again you will say that, sir, just now we have calculated area of triangle ADE, then why we are finding it again? See, this time I am changing base. So accordingly I will take another height for this. Understand, I am taking ADE triangle again. This time base is AE and I am taking height as DM. This is height I am taking. So formula of area of triangle ADE will come half into AE into DM, right? Now I am finding area of triangle DEC, this triangle. Again student, this is an obtuse angle triangle. As I have already explained, this in case of obtuse angle triangle, height lies outside the triangle. So here, if I am taking EC as base and DM as perpendicular, then area of triangle DEC will be half BC into DM. I hope it is clear. It is very similar to this one. Now divide equation number 3 by equation number 4. Okay. When you are dividing, so first area is half into AE into DM. Second area of DEC triangle is half EC into DM. Now cancel half and half, DM and DM, DM, sorry. So it will be area of ADE upon area of DEC will be AE upon EC. These two equations you remember. Now after getting equation A and equation B, go for next slide. Here, students, as you have studied in class 9 that two triangles standing on the same base and lies between same parallel are equal in area. So here you can see that BDE, here you can see that BDE is, BDE triangle is standing on side BD, as well as DEC triangle is also standing on DE, and they lies between same parallel because they have given in question that DE is parallel to BC. So we can say area of BDE and area of DEC will be equal. Okay, so that's why we can say area ADE upon BDE will be equal to area ADE upon DEC. Using this equation you can say this. So we have proved that when a line is drawn parallel to one side of triangle, intersecting two sides at distinct point are dividing two sides in the equal ratio. So this is AD upon DB is equals to AE upon EC. So we have proved this B.P.T theorem. This is very important theorem and many application based questions are coming on this. Let's do some question on this. In next slide we can see. Here student, understand, a triangle is given to you. Example, in triangle ABC given that DE is parallel to AC. You have to find BE. Understand, I told that if a line is drawn parallel to one side, intersecting other two sides, okay, that dividing it in the equal ratio. Just now we have proved in BPT. So students, because line is given parallel, so you know one thing that we can write BD, BD is equals to BD upon DA will be equal to BE upon EC. Now in figure you can see that this whole line is given 12, that is BA, BD is given to you 4. Now when you will subtract, it will come 8. You will get this 8. Now here BC whole length is 24, EC is given X. Now how to find it? BE, here I can say it is 24 minus X. This is BE. Now I will put value in BPT. BD value is 4, DA value is 8, BE value is 24 minus X, and EC value is x. Getting? Now, cancel this 1 upon 2. Now cross multiply 1 into x, 48 minus 2x, right? And minus 2x will come this side. So 3x is equal to 48. X value will come 48 upon 3. What is 48 upon 3? This is 16 centimeter. So students, here you have not got BE. You have got only value of x. This is 16. This is 16. Now, if whole length is 24 and this part is 16, what will be remaining side? This side will be how much? BE will be is equal to 24. BE will be is equals to 24 minus x. 24 minus x, that means 24 minus 8. Sorry, 24 minus 16, that is 8 centimeter. So, your BE answer is 8 centimeter. Okay. Another way of checking is what? 4 upon 8 is giving you 1 upon 2. And 8 upon 16 is also giving you 1 upon 2. So, ratio is same in this case. So, this is question based on basic proportionality theorem. Now students, today's last topic we are completing, that is basic converse of basic proportionality theorem. What is converse of basic proportionality theorem? Theorem is saying if a line divide any two side of triangle in the same ratio, then the line is parallel to third side. If a line dividing two sides in the same ratio, then line is parallel. So, they have given you in question AD upon DB is equals to AE upon EC. This is given part. Okay. And what we want to prove in this? We want to prove that DE is parallel to BC. Okay. For that, what we have to do? We have to think that if DE is not parallel to BC, then there should be another line that will be parallel to BC. Let's suppose that DE dash is parallel to BC. We are assuming that DE dash is parallel to BC. Now student, if I am saying that in the triangle DE is parallel to BC, that means it can follow basic proportionality theorem, and according to that theorem we can write AD upon DB is equals to AE dash upon E dash C. Can we write? Yes. So, just see next. If I am saying that DE is parallel to BC, that means AD upon DB is equals to AE dash upon E dash C. This is our equation number 1. Now, but in question, they have already told that this line DE is dividing it in the equal ratio. That means AD upon DB is equals to AE upon EC is given in question. So, when we equate these two equations, what happens? See, here we have AD upon DB, here also we have AD upon DB. When we are equating these two equations, then we are getting AE upon EC is equals to AE dash upon E dash C. This equation we are getting here. Now understand students, add 1 both sides. Add 1 both sides. So AE plus EC, AE upon EC plus 1 and AE dash upon E dash C plus 1. We are adding plus 1 both sides. After LCM, you will get here AE plus EC, that will be equal to AC. Here you will get AE dash plus E dash C, that will be equal to AC. Now, you can you can cancel AC and AC. So it is 1 upon EC and it is 1 upon E dash C. After reciprocal, you can say that EC is equal to E dash C. Again, you understand? AD upon DB is equal to AE dash upon E dash C, because we are saying that DE is not parallel, then another line DE dash should be parallel. That's why. So AD upon DB is equal to AE dash upon E dash C we got. Then it was already given AD upon DB equal to AE upon EC. Now after equating these two, we are getting result AE upon EC is equal to AE dash upon E dash C. Adding 1 both sides and taking LCM, we are getting here AE plus EC, that can be written as AC. Here AE dash plus E dash C will give you AC. Okay, AC and AC we are cancelling, and you can say that it will come 1 upon EC is equal to 1 upon E dash C. After reciprocal, you can say EC is equal to E dash C. But student, is it practically possible that EC is equal to E dash C? Yes, it is possible only in one case, that E dash should coincide with point E, and this E dash point should come here only as E dash. So E and E dash should be same point. Okay. So if that will be same point, it will coincide. So we can say that DE line will be parallel to BC. Now we are taking example on converse of B.P.T theorem. For this is last for today. Now understand, here I have taken one example. It is given that AC is 36 centimeter given to you, and BC is given 27 centimeter. Okay, this is given. They are saying that you prove that DE is parallel to AB. DE is parallel to AB, we want to prove. Now, for proving this, what we should do, that you see what given in question. This is total 36 is given, okay, and DC is given 20 centimeter. DC is given 20 centimeter. So first we will find AD. Okay. How we will find AD? 36 minus 20. So we will get 16 centimeter. Similarly, here they have given us EC. This is given to us 15 centimeter, and BC is 27 centimeter given. So first we will find BE. BE will be what? BE will be 27 minus 15, that is 12 centimeter. Now you find ratio of the side. If ratio of the sides are coming equal, then it will be parallel. If this line dividing it in the same ratio, it will be equal. How? First I am finding AD upon DC. AD upon DC, I am getting 16 upon 20. Okay, and after cancellation I am getting 4 upon 5. Now I am finding BE upon EC. BE is 12 centimeter and EC is 15. When I will cancel it by 3, 3 4 ja 12 and 3 5 ja 15. So student, here also we are getting 4 upon 5. So what we can say? We can say in both case AD upon DC and BE upon EC are coming 4 upon 5. So they are equal. If sides are divided in the same ratio by any line, then it is proved by converse of B.P.T that line will be parallel. DE is parallel to AB by converse of B.P.T. So student, we have done today congruent figure, similar figure, criteria of similarity. Then we have done about B.P.T theorem, its example. Then we have done converse of B.P.T and its example. So you revise all these things and then we'll meet in next class. Thank you so much.